Hi, everyone. I'm Doug Black, editor-in-chief at Inside HPC. And today, as part of our series of interviews on behalf of Hyperion Research, we're with Hyperion's Alex Norton. He is Principal Technology Analyst and Data Analysis Manager. And today we're talking about Alex's presentation on the state of AI that he gave at a special Hyperion event last month in Washington. Alex, welcome.
Hi, Doug. Thanks for having me.
All right, great to be
Excited
with
to
you.
talk about AI.
Awesome. So tell us, if you would, give us a brief overview of your presentation, if you would.
Sure. So where we like to start when we're talking about AI is really the part of the market that we focus on. When we talk about AI, we really talk about the pointy end of the spear of AI. And we're looking at workloads, specifically large training workloads being run on large systems. So we focus primarily on that. We focus less on the downstream AI applications, except for how they manifest from the training models. We also focus very heavily on kind of the impact that AI is having on the data center ecosystem, both for on-premises systems and cloud deployments. And then we also focus on the different methodologies being used in the AI space, kind of looking at the growth of machine learning, the promise of deep learning, and then some of the emerging methodologies that are growing in the AI ecosystem. From a market perspective, as with all Hyperion Research areas of focus, we do track a 5-year forecast. Without going into too much detail, the key focus point, key focal point of this market for us is the growth rate. The growth rate of AI dedicated systems or AI focused systems is more than 2 times greater than the overall HPC server market. And this market is growing to be a much more crucial and important component of the overall HPC ecosystem. In terms of how AI is impacting data centers, one of the things we've seen is an aggressive rise in growth in GPU adoption in the HPC space. Originally, GPUs were being used only for AI training, but as user sites have GPUs installed on-prem, we're starting to see a modernization of legacy HPC code to take advantage of GPUs when they're not running AI workloads. We're also seeing a number of different system architectural decisions being taken by different HPC data centers. We see some sites that are building small dedicated systems for a subset of their workloads, and we see other sites building large heterogeneous systems to address a wide variety of workloads. That would include traditional simulation, big data, and AI. And then finally, we're seeing cloud increase in adoption as well, specifically in the AI space, because of the access to more flexible GPU resources, access to different tools and services that are only available, and access to the knowledge and expertise that the CSPs have in some of these more data-intensive workload spaces. In terms of the technology that we're tracking, we follow the components very closely. We've been tracking the rise of Nvidia GPUs, as well as the emergence of new companies into this space targeting AI acceleration. There was the 5th annual State of AI report came out in October of 2022. And one of the interesting findings from that report was that the valuation of Cerebras Systems, SambaNova, and GraphCore, which are 3 of some of the bigger and more prominent AI accelerator companies, the combined private valuation of those 3 companies does not exceed the annualized data center revenue in 2021 by Nvidia. So while these companies do present an interesting alternative and more specialized alternative to the general purpose GPU, Nvidia still holds the lion's share of this market. We're also tracking the uptick in the adoption rates and promise of both Intel and AMD's GPU lines. AMD's GPU line was chosen for 2 US exascale machines, and Intel is preparing to bring their data center GPU Max to the markets very soon. In terms of the importance of AI, we're really trying to understand and focus on the value that AI workloads present to the world, more specifically to the science and engineering spaces. So looking at how AI can accelerate drug discovery or how it can support weather and climate forecasting, but also looking at how AI has already made critical advancements in things like automated driving and security. And we're looking at the intersection of those two things. Speaking of intersections, we're looking really at how AI and HPC are both converging, as well as how they're supporting each other on separate paths. So we're seeing a number of interesting standalone AI models being trained, interesting AI problems being tackled, but also seeing AI incorporated as a tool into traditional simulation workloads. On the other hand, we are also seeing traditional HPC simulation workloads supporting AI through synthetic data generation, through verification and testing of models. And so we're seeing a really healthy symbiotic relationship between HPC and AI in this space. On the user side, we're seeing two main groups of users emerge. This is not meant to say that this covers every type of user, but we're seeing a number of users who are in the experimental or the start phase of their AI journey. They're working on relatively small scale models. So they're learning how and where AI can be useful and helpful for their work. On the other end, we're seeing AI researchers who are really pushing the boundaries of AI. They're training extremely large models in the billions to trillions of parameters on massive systems through large teams with extensive skill set in this space. And there is overlap with science, but there are also efforts to train more general AI models for the entire ecosystem. And then finally, one of the interesting kind of components of AI being adopted more widespread in the general ecosystem is the approachability of it. It's one thing to work and dive into AI research, but it's another to make it understandable in all kind of downstream applications. An interesting example is the ChatGPT that was released in the November-December timeframe of 2022, which made AI much more approachable from the average person without having to understand the complexity and the capability that sits behind it. And it's an interesting and a crucial first step in making AI much more approachable and much more understandable as it gets introduced into more downstream applications. And with that, that was a brief overview of what I talked about.
Okay, great stuff. Let's talk a little bit about the key distinctions between big AI strategies and workloads, in the enterprise over against those in the national labs, supercomputing centers, and academia.
Sure. So looking at kind of the different types of workloads, it's important to focus one on the purpose of the entity that's doing the work, as well as what the ultimate downstream application will be. If you look at academia and some of the national labs, a lot of their focus is on fundamental research. So pushing the boundaries of AI, pushing the capabilities of AI, and making their work available for many different disciplines. Within the private sector space, a lot of what they do is tied to bringing new capabilities and new experiences to their customer or user base. So they're much more finite in the goal and the intended use of AI. That's not to say that there aren't private institutions that do really interesting and important research in this space, but they have two different goals, and they also have two different infrastructure setups. Many of the national labs have very, very large HPC systems with GPUs, and so they can train much larger models than some of the private institutions. So you're seeing a difference in the scale and the capabilities of these different groups as well.
Okay, now, we've heard for several years now regarding the relationship between HPC and AI, and certainly lots of talk about the convergence of the two. But lately I'm hearing more discussion of the divergence. I mean, are both of these trends happening at the same time, or is there more of weight behind one or the other?
It's a great question. We are seeing both convergence and divergence. Um, Personally, I think some of the more interesting use cases exist at the intersection of HPC and AI in using AI techniques to accelerate traditional simulation, as well as searching through new solution spaces that are either not physically possible or not yet explored. So on the convergence side, we are seeing a lot of work being done to combine AI techniques and traditional physics-based simulation. But we are also seeing some stuff on the divergence side as well. I think an interesting part to consider when combining traditional physics-based simulation and AI is getting engineers to trust the output of AI models in context of their physics-based simulations. Um, you have to trust that the output is accurate enough or that the error will not factor into the final result. So there's a lot of trust that has to be built between AI engineers and physical scientists. But we are seeing both. Personally, I think that convergence applications are really interesting and are kind of going to continue to grow as new solution spaces and new application spaces are explored.
Okay, now on the AI processor end of things, you stated Nvidia continues to dominate with its GPUs over against companies like, especially AI chip companies like Cerebras and Samba Nova, who haven't really caught on yet. Why haven't they caught on? And the new GPUs from AMD and Intel, do those pose a threat to Nvidia's leadership?
Yeah, so the AI chip companies are right now still pretty niche. There are some customers who and users who have adopted those technologies, but in terms of looking at widespread adoption, one of the things that Nvidia has done very well is one, they were first to the game, but they've also created an entire software ecosystem that sits around their very capable hardware. And so as users have adopted their technology over the last 5 years, they've learned CUDA and they've brought CUDA into their programming environment. And so when they are looking at running jobs that require accelerators, especially in the AI space, everything that they have built is already in CUDA. Now, migrating to a new software paradigm or new programming paradigm is not the end of the world. It can be done, and many users are doing it. But it does take effort and it does take time. So there are a number of sites who are still content and get great performance out of staying with the platform that they have established. An interesting comment that I heard from some users is that technologies like Cerebras or Samba Nova, you have to have an application that really requires that type of technology because it is so new. That you can't just test around for a year on it. The barrier to entry can be slightly higher, more expensive than traditional NVIDIA gear. So that might be why they haven't caught on. But Intel and AMD are growing in the space, and we do expect them to pose a threat in the short term and in the long term to NVIDIA's market share.
Yeah, and we know that these new exascale class systems at the national labs, one, Aurora and Argonne will be using Intel GPU,
Mm-hmm.
and El Cap and Frontier are powered by AMD GPU. So that's kind of interesting.
Yeah.
We've also heard for years about there's a chronic AI skills shortage. Are there more effective efforts coming online from on the corporate side or on the academia side on AI training?
So one of the things that we're seeing is that especially in academia and undergraduate and graduate studies in scientific fields, and that's physical sciences, kind of other human sciences. Students are being introduced to AI techniques at an earlier time. It's not just computer scientists now who are being taught how to program in TensorFlow or PyTorch or R. It's being made available to a number of different fields. So there is some work being done so that when scientists come into the workplace or into the research field out of college, they have a general base knowledge of how to run AI workloads. The key there is really to create a general level set knowledge base and language so that domain scientists and AI experts and HPC experts can all communicate effectively together with a similar knowledge base and a similar verbiage. And so that way they can effectively communicate about what they need from each other in order to pursue their research goals. But there's still definitely more that can be done in creating more experts in this space, providing more capabilities even down into high school and middle school and STEM and computer science. But there are efforts underway to create a more robust workforce.
Okay, why don't we finish on the topic of generative AI? So two of the biggest tech stories of this year are around that area of AI. There was the Lambda chatbot at Google, in which a Google engineer asserted that Lambda is a person with a soul. And then ChatGPT came out, I think, late November, and had more than 1 million downloads in less than a week. And I've used it. It's truly amazing. I mean, it's not perfect, but it is amazing what it puts together so rapidly for you. It kind of makes me wonder, and I wonder if you have thoughts along these lines, this kind of AI, generative AI, combining search and natural language processing, where will this all be in 5 to 10 years if it's already this far, if it's already at the state it's in now?
I think it's going to be in a really interesting place. It's a topic that I think about often and also try not to think about as often as I do. I saw a really interesting presentation just last month about the idea of empathetic AI and AI that can have emotions and can sense emotions. And so I think, the trend and the path towards more capable AI entities in mimicking human capabilities, we're definitely going along that path. I'm unsure of how quickly we'll get there and what the reception will be, but we're definitely pushing more towards into sentient AI, or general AI is a term. Artificial general intelligence is a term that's being used now for something that's much less narrowly focused on a specific area of knowledge and being more general in all knowledge, the way that human beings are. And there has been some talk about how big of a model do you need to build to replicate the human brain, and the capabilities of that brain. And emotions are part of that, and scale is part of that, but also training on many different types of data and many different sources of data. So we're definitely moving in that direction. 5 to 10 years could be really interesting. I think part of it will depend on how human beings feel about computers feeling.
Yeah, exactly. It's really going to be fascinating to watch. So, Alex, thanks so much for your time. We've been with Alex Norton of Hyperion Research, and we'll talk again soon.
Thanks, Doug. Have a good one.